All right, Assalamu alaikum. Today we are doing February March 2023 IGCSE Chemistry Paper 4 Variant 2. In February March, there seems to be only Variant 2 uploaded on the website, anyways. So let's look at the first question. This question is about gases found in clean, dry air and gases found in polluted air. Name one gas found in clean, dry air which contributes to global warming. So, which gas found in clean, dry air contributes to global warming? The only answer is carbon
Carbon dioxide.
dioxide, because in air the only greenhouse gas present is carbon dioxide. All right, next question, state the percentage of nitrogen in clean dry air. It is
78.
78%. Good. All right, next, name the substance used to remove sulfur dioxide in flue gas desulfurization. Which substance do we usually use? We use calcium oxide, or we sometimes use calcium carbonate as well. Basically, calcium carbonate can also be and is also used in flue gas desulfurization. Calcium carbonate would also be considered correct. Okay. Next
So
question.
what do they mean by flue gas desulfurization?
What is flue gas desulfurization? So in the environmental chemistry bit, we study that many factories they produce sulfur dioxide. Okay. Sulfur dioxide is what we call flue gas. Desulfurization, basically the flue gas, we remove the sulfur dioxide out of it. How do we remove it? By putting basic oxides and we dampen them. Matlab, these are wet and they are placed on the chimneys of these large industries. So the industries have chimneys, and on the walls of the chimneys there is calcium oxide. Now when sulfur dioxide moves up the chimney, it reacts with the calcium oxide and produces calcium sulfide salt, and sulfur dioxide never escapes in the atmosphere. This is called flue gas desulfurization. Okay.
Okay.
Next question, nitrogen dioxide NO2 is formed in car engines. Name the equipment in a car exhaust used to remove NO2 from the car engine. How do you remove NO2 from the car engines? So, what do you call it? Catalytic
Converted.
converter. Good. Catalytic converter is the material inside a car engine that you use that we use, and which helps us remove nitrogen dioxide safely. How does it help us remove nitrogen dioxide safely? It converts nitrogen dioxide into nitrogen and carbon monoxide into carbon dioxide. All right, next question, all gases diffuse. Choose from the list of formula the gas which diffuses most quickly. Draw a circle around your answer. So which gas diffuses the fastest? So obviously the gas which is lightest in weight, and I think CH4 is the lightest weight gas. It has a weight of 16, right? No other gas has a weight of 16, I believe. This is 44. Carbon dioxide, carbon monoxide is 28, very famous. Sulfur dioxide is 32 plus 32, that is 64, right? And NO2 is 14 plus 32, so that should be 46, right? 14 plus 32 is 46. So the lightest gas is CH4. All right, next, explain your answer. It has the lowest atomic mass. It has the lowest molecular mass, not atomic mass, we say molecular mass. ठीक है? State one adverse effect of carbon monoxide on human health. It is toxic. All right, it is toxic, and if you want to explain it, it binds permanently, या फिर यूं लिख लो, it decreases the oxygen carrying capacity. It decreases oxygen carrying capacity of the body. It decreases oxygen carrying capacity of the body. Next, carbon dioxide CO2 is a reactant in photosynthesis. Name the two products of photosynthesis. The two products of photosynthesis are glucose and oxygen. We have to write the name, don't write the formula. Glucose and oxygen. Next, complete the dot and cross diagram for carbon dioxide. This is present in our notes, so we can just do this, and this. And then oxygens, they have two extra electrons each, meaning they have two pairs of extra electrons each, right? Like this. Okay, so this is what you have to draw. Next, Lithium and sodium and potassium are group 1 elements. Name the type of bonding in these elements. What type of bonding is present in these elements? Metallic.
Metallic.
Good. Metallic bonding is present in these elements. Next question. Sodium reacts with cold water to form hydrogen gas and a solution strong alkali. State the test for hydrogen gas. Bring a lighted, this is something you have to memorize, splint near source of gas. Near source of gas. What is the positive result for it? The positive result for the reaction is a squeaky pop, squeaky pop sound is produced. Squeaky pop sound is produced. Suggest the pH of solution of a strong alkali, something like 13 maybe. 13 is sounds right. Okay. Next, name a substance which can be used to confirm the pH of a strong solution of strong alkali. What could you use to check the pH of a strong alkali? Solution.
Universal indicator.
Very good. You could use universal indicator. The reason why you say universal indicator is because they said substance. If they had said name the device, then you could not say universal indicator. Then you would have to say a pH meter. Then you had to say a pH meter. Right now you say a universal indicator because universal indicator is a substance. All right. These are things you have to keep in mind. Next question. Write the symbol equation for the reaction between sodium and cold water. Include state symbols. So sodium or any group 1 metal is called an alkali metal because by definition they react with water and they produce alkaline hydroxides. Meaning this guy will produce sodium hydroxide and hydrogen gas, right? Now, state symbols are required. This is solid, this is liquid, sodium hydroxide dissolves in water, this is aqueous, and hydrogen is gaseous. ठीक है? सही है? So, hydrogen is gas, then you have to balance the equation. There is 2 and 3. So, you put a 2 over here, put a 2 over here, and put a 2 over here, and everything is balanced. All right? This is a 3-mark equation that was straight up placed in your notebooks as well, in your notes. All right? Next question. Next question is state lithium has two naturally occurring types of atoms, 6Li and 7Li. State the name given to atoms of same elements with different nucleon numbers. It's called isotopes. What is it called? Isotopes. ठीक है. Next question. Complete table 2.1 to show the number of protons, neutrons, and electrons in the atom and ion of lithium shown. All right, so number of protons, each lithium has 3 protons. Beta, this is something you can memorize or remember. This guy has 6 because subtract 6 from 3. This guy has 4. Oh, sorry. This guy has 3 because subtract 6 from 3 is 3. All right, and this guy has 4 because subtract 7 and 3, you get 4. Number of electrons, so lithium, when it is neutral, will have 3 electrons because everything has same electrons as protons. All right, but this one has +1 charge, meaning it has lost 1 electron, so it has 2 electrons. All right. Next question. Table 2.2 shows the relative abundance. Calculate the atomic mass of one decimal place. All right. So you want to calculate the atomic mass to one decimal place. The question is very simple. The formula is summation percentage abundance multiply by isotopic mass, relative isotopic mass divided by 100. All right. So we do one bracket of abundance 10% multiply by 6 plus 90% multiply by 7 divided by 100. And the answer we get, we just write it in the relative atomic mass. So just do 10 times 6 is 60. What is 90 times 7? Not 70, 7 only, right? 90 times 7. So 90 times 7 should be 630 plus 60 divided by 100, you get 6.9. All right. So the mass of lithium is 6.9. I mean, we could have kind of done it in our mind as well because 90% closer to 7 is 6.9. Potassium oxide K2O is an ionic compound. Complete figure 2.1 to show electronic configuration of ions in potassium oxide. Show the charges on the ions as well. Potassium has a +1 charge. Oxide has a -2 charge. All right, and potassium once again has +1 charge. We should know that potassium has four electron shells. It's in period 4, but when it loses one electron, it is left with 3 shells, right? So 2 shells were drawn. We just had to draw the third one. The third shell is going to have all 8 dots. The third shell is going to have all the 8 dots. All right, and the exact same shell should be drawn on this potassium as well. All right, it should be drawn on this potassium as well. And then in the middle one, we want to make another circle. Oh no, we already have the circle. Oxygen has 6 electrons of its own and it gains 2 electrons. So it gains 2 electrons. 1 electron should be gained from each potassium. That is how it works. All right, so oxide ions, that is why has a -2 charge and is shown with 2 dots in its structure. All right, next question. The Haber process is used to manufacture ammonia. State the main source of each gas used in Haber process. What is the source of nitrogen in Haber process? It is basically fractional distillation of liquid air, right? Fractional, well, we could just say air as well, but I don't know why I'm just choosing fractional distillation of liquid air. So you know the process of how we obtain nitrogen. Fractional distillation of liquid, liquefied air. All right. And how do we obtain hydrogen? Well, hydrogen is obtained from two places. It is also obtained from natural gas, right? It is also obtained from natural gas, and it is found underneath beneath Earth's crust with natural gas. So basically, it is found along with natural gas. All right. And I don't know which student, I think it was one of you, had asked me, sir, I wrote beneath the Earth's crust, but the marking scheme said a reaction of methane reacting with carbon monoxide, I believe it was, and it was producing carbon dioxide and hydrogen gas. And they said this is how hydrogen gas is produced. Is that so? Yes, that is so. I had said that is the main reaction by which we convert methane into hydrogen. All right. So writing natural gas is not a problem. The thing is, um, natural gas is basically just methane, and along with that, it is also a few more things. Okay. The next question is the equation for Haber process is shown. Nitrogen plus hydrogen gives ammonia. Delta H is -92 kilojoule per mole. The reaction is reversible. The forward reaction is exothermic. State what is meant by the symbol delta H. So what do we mean by delta H? Delta H means enthalpy. Enthalpy change. All right. Next question. Delta H for the forward reaction is -92. State why this value shows that forward reaction is exothermic. The value is negative. The value is negative. All right, the negative value shows that forward reaction is exothermic. State the typical conditions and the name of catalyst in Haber process. So what temperature do we use? We use 450 degrees Celsius temperature, right? What is the kilopascals of pressure? Beta, we don't know, but we know 200 atmosphere, right? So over here, just remember okay, 1 atmosphere is how many kilopascals? 100 kilopascals. How many kilopascals is 1 atmosphere? 100. So 200 atmosphere would be how many kilopascals? It would be 200 times 100. So 4 zeros. So it should be 20,000 kilopascals. All right. 20,000 kilopascals. All right. And then catalyst should be iron, just iron. All right. Not iron beds, just iron is fine. Okay. Complete 3.1 to show the effect, if any, when typical conditions in the Haber process are changed. Use only words increase, decrease, or no change. All right. So if we increase the temperature, the forward rate of reaction increases. But what would happen to the equilibrium? Since forward reaction is exothermic, increase in temperature will decrease the yield of NH3. ठीक है, तो it will decrease the yield of NH3. Even though forward reaction happens faster, forward reaction will stop earlier as well. Like before it was stopping or it was becoming constant at 60%. Now increased temperature would make it constant at 50%, 45%, something like that. If we decrease the pressure, what would happen? So you know that forward reaction is exothermic. उसकी बात हो गई है. ठीक है, I'm just showing you how you could have done. You write like this exo, you write like this endo, and forward reaction you write like this endo, and forward reaction is exothermic, which means that delta H causes um, delta H is negative, right? And increase in temperature causes backward reaction more, right? It does increase the rate of reaction because increase in temperature always increases the rate of reaction, but yield will be less because endothermic side will be favored. Now let's talk about pressure. This side has 2 moles of gas, this side has 4 moles of gas. If we decrease the pressure, then first of all, the rate of reaction would decrease. Obviously, why? Because decrease in pressure decreases the rate of reaction of gases because they become further apart, so less particles per unit volume. That is how you define it. Okay, so reaction will decrease, and what will happen to the equilibrium concentration though? If you look at the forward side has 2 moles of gas, right? We say forward side has 2 mole of gas, and backward side has 4 mole of gas, right? So which means that this decreases. All right, so it decreases. When we don't have a catalyst, what happens? No change happens, because when you add or remove a catalyst, only the rate of reaction is affected, but not the position of equilibrium, which means that concentration should not change. Next, explain in terms of collision theory why increasing the temperature increases the rate of reaction. Because increase in temperature increases. It is a 3-mark question right now. All right, so we have to marinate it to the maximum. Increase in temperature increases the average kinetic energy of particles. Yeah, reactant particles, right? Write the whole thing of reactant particles. Full stop. Next, hence particles move about more quickly and collide with each other with greater force. Stop. This increases the frequency and chance of a successful collision SION collision, hence increasing the rate of reaction. First up. Next question. Ammonia reacts with an acid to form ammonium sulfate NH4 whole twice SO4. State the formula of the acid used. So which acid should be used? If sulfate is produced, then we need sulfuric acid H2SO4, right? So we need sulfuric acid, otherwise we can't. All right, state one use of ammonium sulfate. So ammonium salts, what do we use them in the nature, in the world? What do we use them for? We use them for useful fertilizers. We use them for fertilizers. Calculate the percentage composition by mass of nitrogen in ammonium sulfate. The percentage by mass or percentage composition has a simple formula. All right, that formula is mass of that atom, mass of atoms of elements divided by MR of compound, MR of compound. So if you observe closely, you will see that nitrogen is twice in this equation. So we will say 2 nitrogens upon MR of NH4 whole twice SO4. All right. Now the students who have practiced so many times now should become familiar with everything. The mass of ammonium is 18. If you guys have practiced it enough times, you will start to remember. All right. Nitrogen is 14. The mass of ammonium is 18. So 2 times 18. All right, because two ammoniums plus the mass of sulfate is actually 96. That is also something you can remember. SO4 is 96. How do I know that? Sulfur is 32 and 4 oxygen is 64. Add the two values together, it gives us 96. All right, so 96 multiply by 100 as well. That is also something we have to put, right? Multiply by 100 and multiply by 100. All right, so it becomes this 2 times 18 is 38, right? 2 times 18, 36, sorry, plus 96 equals to 132. You divide 28 by it. All right, so it becomes 28 divided by 132 multiplied by 100. All right, so whatever was divided by answer, you multiply the answer by 100 and you get 21.21%. All right, so the final answer is 21.21%. All right, the answer is 21.21%. And did they tell us to write it in how many significant figures? They have not, so we just write 21.21%. There is no problem with that. Okay, copper is element 29 in the periodic table. Brass contains copper. Name the other metal in brass. So the other metal in brass is zinc. All right, it is mentioned in the notes. A few of the alloys in this world we have mentioned, the famous ones, and one of them was brass. So brass contains zinc. Next question. State the term given to mixture of metal with another. Wow, I just used the word alloy. This is what alloy is: mixture of one metal with another metal. Next question. Copper can be stretched into wires. Copper wires conduct electricity. Name the product property of metals, which means that they can be stretched into wires. That property is called ductility. Ductility. All right. Ductility is the property of metals which causes them to be drawn into wires. Okay. Name the particle responsible for the conduction of electricity in solid copper. The particle is called electron. Particle is called electron. Next question. Copper is a transition element. Some physical and chemical properties of transition elements are shown. Physical properties: high density, high strength, वगैरह वगैरह. Chemical properties: form colored compounds, have ions with variable oxidation numbers. State one other physical property of transition element. All right, so they form colored compound. They have variable oxidation numbers. All right, we want to tell one more physical property. Sorry, so that is
Can we
physical
write
property.
that it has a high melting point?
High melting and boiling point is correct. Okay, high melting and boiling point is correct. All right. All right. Next, state one other chemical property of transition elements. So there were only
Catalyst.
three. Yeah, there were only three specific properties of transition element. Two of which are written over here. The third one is that they act as. They also act as catalysts. Next question. Hydrated copper 2 sulfate is a colored compound. It exists as hydrated crystals which contain water molecules. State the term given to water molecules present in hydrated crystals. Hydrated copper 2 sulfate is a colored compound. It exists as hydrated crystals which contain water molecules. State the term given to water molecules present in hydrated crystals. ठीक है, तो hydrated crystals के अंदर
Water crystallization.
जो वेरी गुड जो वाटर मॉलिक्यूल जो हाइड्रेटेड क्रिस्टल के अंदर फंस जाते हैं, दे आर कॉल्ड वाटर ऑफ crystallization. They are called water of crystallization. Next question. State the color of hydrated copper 2 sulfate crystals. Hydrated copper 2 sulfate crystals का color क्या होता है बेटा? It is blue. How do we know that? This is also a test. You have to remember it. Next, write the formula of hydrated copper 2 sulfate. CuSO4 dot 5H2O. It seems that in 2024, in February, March, they asked you this formula, and then they also asked you this formula in October, November. All right. So they have asked us this formula twice now. All right. And this is the only formula of hydrated compounds that we should remember other than cobalt 2 chloride. Because pink cobalt 2 chloride, you should also remember, in that water is 2, 2H2O, all right, for cobalt 2 chloride. I don't know, they might ask in the future. All right, cobalt 2 chloride contains 2 water of crystallization molecules per formula unit. So the formula becomes COCl2 dot 2H2O. Okay. Next question, copper 2 oxide is formed when copper 2 nitrate CuNO3 whole twice is heated. Okay, so what? State the class of oxide to which copper 2 oxide belongs. It is a basic oxide, right? Because class of oxides are 4: basic oxide, acidic oxide, amphoteric oxide, neutral oxide. Neutral oxide we don't study, we just know carbon monoxide is a neutral oxide. Okay. And acidic oxide we study, non-metal oxides mostly. All right, amphoteric oxides, just a few we have to remember: zinc oxide, lead oxide, and the third one was aluminum oxide, right? And then basic oxides are all other metal oxides. State the meaning of the Roman numeral 2. It has oxidation state of +2. It has oxidation state of +2. So Roman numeral 2 means that it has an oxidation state of plus. Next question. 0.02 moles of CuNO3 is heated. Calculate the mass of 0.02. So mass is equals to mole multiplied by mr. All right. So 0.0200 multiplied by mr of CuNO3 whole twice. They told us the mass of copper at the beginning. We can just use that one. No, they told us the atomic number. So we have to go downstairs and we have to search. Let's just rotate this, brother. All right. Do we have copper? Where is copper? The mass of copper is 64. All right. Nitrogen is 14, we know, and oxygen is 16, we know. Copper nitrate होगा, ठीक है? So the mass of copper is 64 plus the nitrates 2 times nitrogen is 14 plus 3 oxygens is 64. All right, and then bracket. Okay, so this becomes 0.0200 multiplied by, so what is 14 plus 64? That is 14 plus 64, 78 times 2, that is 156, plus 64, that is 220. So this will be equal to multiply by 220 multiply by 0.02. What is the answer? Answer is 4.4. So what is the mass? 4.4 grams. All right, 4.4 grams. That is the first answer. All right, next question. Calculate the total volume of gas in dm cube at RTP produced when 0.02 moles of copper nitrate is heated. Total volume of gas produced when copper nitrate is heated. All right. So total volume of gas. So total volume of gas produced is
Wait,
5
sir,
moles.
I got a
G.
different answer for the first question. I think I did some mistake with the MR.
What did you get, beta?
I got 3.7 something.
बहुत बड़ा difference आ रहा है. Okay,
Wait,
3.7.
I
So
think
let
I
me,
did some mistake in the MR. I think so.
let's see.
The MR
14 plus 3 oxygens. Sorry, yeah. 64 is not the right answer. This should be 48. 3 oxygens is 48. 14 plus 48 is 62. Times 2 is 124. Plus 64 is 188. So this is going to be 100.
188, right? Yeah, okay.
Yeah, 188. Okay. So multiply 188 by 0.02. That should give us 3.76.
Yeah.
3.76.
G, I got the same answer.
All right. So we don't need to make a line because we can do it down here. The total volume of gas. So for total volume of gas, we have figured out that 2 moles of CuNO3, 2 moles of CuNO3 whole twice produces what is the volume of gases that it produces? And let's write it like this: to the volume of NO2 plus O2, because these are the two gases that are being produced, right? So the ratio is 2:5. All right. So mass is not necessarily required. We just need 0.02. So 0.02 is going to obviously produce 0.0500 moles, right? We don't have to do anything else. And then we'll say volume of gases. Okay. So volume is equals to mole multiplied by 24. Okay. Moles are 0.05 multiplied by 24. So 0.05 multiplied by 24, that should give us 1.2 dm cube. All right, the answer is found in dm cube because the question asked us to. 1.2 dm cube, that should be our final answer. Next question: powdered aluminium reduces copper to oxide. Write the simple equation for this reaction. So to write the simple equation, simple equation, not the ionic equation. So it's very simple. Aluminium, it reacts with copper oxide, CuO, and it produces obviously aluminum oxide. Aluminum oxide is Al2O3, and this is copper. To balance the equation, we put a 3 over here and a 2 over here and a 3 over here. All right, everything is balanced now. Okay, we did not have to put symbol equation, state symbols for it. On to the next question, question number 5. Propanoic acid, propene, propane-1-ol, and propanoic acid. Propane, propene, propan-1-ol, and propanoic acid are members of different homologous series. Molecules of these substances contain 3 carbon atoms. Explain why members of homologous series have similar chemical properties. Why do they have similar chemical properties? It is because they have the same functional group. They contain the same functional group. All right, members having same homologous families have same homologous families because they contain same functional group. Name the homologous series to which propanoic acid belongs. It belongs to the family of carboxylic acids, right? Next, state the general formula of homologous series to which propanoic acid belongs. The general formula, there are two. Write the more obvious one, CN, H2N, O2. Otherwise, you could also write the other formula, which was CN, H2N plus
H2N
1,
plus COH.
COOH. But you just have to, when applying it, you just have to consider that N is 1 less than the total number of carbons. Next, propane-1-ol has an unbranched isomer. Name this isomer. Propane-1-ol has an unbranched isomer, and we have to name that isomer. All right. So first we have to draw propane-1-ol to learn what propane-1-ol looks like, beta. All right. Propane-1-ol looks like it has OH on the first one, and then all the others are hydrogens. All the other brothers are hydrogens, right? So the isomer that we could observe of propane-1-ol could be one in which there is the functional group switching, right? Switching of the functional group like this. If the functional group was on the second carbon, then automatically now the substance's structure is different, but its formula is same, and it will be called propane 2-ol. All right, it will be called propane 2-ol. That is the displayed formula. All right, this is how you draw the displayed formula. Actually, you just draw one more bond, because displayed formula you need every single bond shown. All right, so you have to draw another H with O like this. Okay, so that is propane-1-ol. That is propane-1-ol, and then the displayed formula should contain propane 2-ol like this. All right, next question. Propane and propene can be manufactured by heating decane C2H10 H22 C10H22 in the presence of catalyst. One other product is formed. Okay, propane and propene can be manufactured. All right. Um, so three products are formed. First is propane. Propane is C3H8. Propene is C3H6. So how many hydrogens have been used? Three and three. Six hydrogens have been used. So the other
So
product should be
C4.
C4. And then how many hydrogens have been used? 8 and 6, 14 hydrogens have been used. So what is 22 minus 14? It's 8. So C4H8 butene is produced. Name this manufacturing process. This process is called
Cracking.
cracking. All right. Next question. Propene forms a polymer named polypropene. Draw the displayed formula of a section of polypropene showing 3 repeat units. So we want to show polypropene. All right. So first of all, for showing polypropene, you want to draw propene. So carbon, carbon, double bond, and carbon again. And then this is hydrogen, 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 this guy is hydrogen, and like this. Okay, so this is polypropene, right? This is just a simple form, monomer of propene. Now to make it into an addition polymer, first of all you have to do a little bit of cosmetics on it. Okay. What is meant by that? Basically you want to have the lefts and rights empty. This side and this side should be empty. All the bonds should go up or down. So for example, this bond is on the side, this can go down because the downside is empty. So just shift it down, shift this up, shift this was already up, and shift this whole thing down. Now you can shift this whole thing in a condensed way like this as well, because it is useless, it is just there. Okay. Now how do you draw the displayed formula? The answer is very simple. You draw a bond, you draw a carbon. All right. And then
Wait, sir, can you repeat how you did that?
yes, I can absolutely repeat how I did that. Basically look, this much you can see is already here, right?
Yep.
What you need to do is you need to have these sides empty. Okay. Right
Yeah.
now this side which you need to keep empty has a hydrogen. Just shift it downwards. So draw it down here.
Okay.
Okay. Now this side, this can be condensed into CH3 because it is not going to take part in the chemical reaction. Once you condense it into CH3, shift it down over here.
All right.
So now this side and this side are empty.
Yeah.
Nay, the thing
Oh.
is finished. It's finished. It's empty. That is what I just did.
Okay. Okay. I got it. Yeah.
Okay. Carbon bonded to another carbon, and then double bonded this. Okay. And then we need to have bond over here. We need to have bond at the bottom. We need to have bond over here. All right. And over here there was a CH3, and these three were just hydrogens. All right. And then we want to draw 3 repeat units, so we will just draw 3 repeat units. All right, like this, and then like this. And if you want to highlight in your exam, you can have these guys red or some other color. I mean black, you can have them. Or if you do with pencil, just have them highlighted or something, that these are the repeat units. These are the bonds that are joining the monomers. All right, these were previously the double bonds, they are not the double bonds anymore. Okay, so this is how you do it.
But so why'd you draw that double bond in between, Joe?
What do you mean?
The
Sorry,
double
sorry.
bond
Yeah,
in
the
between.
double bond will go. The double bond will go. My bad. My bad. There will be only one bond between them. All right, just one bond between them. Okay, state the type of polymerization that occurs when propene forms polypropene. The type of polymerization which occurs is called
Addition.
addition polymerization. All right, addition polymerization. Next, propanoic acid reacts with aqueous sodium carbonate to form a salt. Suggest the name of the salt formed. So if sodium carbonate reacts with propanoic acid, it will produce sodium propanoate, because the anion of acid that is over here is the propanoate anion. All right. Suggest the formula of the anion of this salt. For that, we need to know the formula of propanoic acid is C2H5COOH, right? So if it reacts with sodium, it will produce C2H5COO, and at the last H, Na will replace, and along with that hydrogen is produced. Because Na has +1 charge and alkanoate has -1 charge, that is why the formula is C2H5COO Na. In some exams, they have reacted propanoic acid with calcium. All right, they have also reacted propanoic acid with magnesium. All right, so you have to judge what the formula will be from the ionic formula or the ionic charge. Like C2H5COO has an overall charge of -1 and sodium has an overall charge of +1. So that is why the formula is C2H5COONA. Next question.
But sir, they're only asking for the anion, so isn't it only going to be Na?
Wow, they are only asking for the anion. Yeah, so it's only going to be CaCCOO minus. All right,
Oh yeah,
the
anion.
anion
Okay,
will be CH3COO minus. All right. Next, propanoic acid forms an ester when it reacts with ethanol in the presence of catalyst. Suggest a suitable catalyst. So we want to know about the catalyst. The catalyst and the dehydrating agent is the H2SO4, right? So H2SO4, sulfuric acid. Sulfuric acid is a very famous dehydrating agent and a catalyst used in the manufacture of esters. All right. Next, name the ester formed. If propanoic acid reacts with ethanol, it will produce ethyl propanoate. How do I know it will produce ethyl propanoate? Because ethyl propanoate is the ester. Every time an ester forms, its name sounds like alkyl, alkanoate,
no.
and alkyl part determines the alcohol. Basically, meaning the alcohol tells us the name of the alkyl part, and the alkanoate part comes from the carboxylic acid. Now, if you observe, the alcohol is ethanol, so that is why its name is ethyl, and the carboxylic acid is propanoic acid. That is why its name is propanoate, carboxylic acid. Next, draw the displayed formula of this ester. So we want to show everything. So carboxylic acid, propanoate contains 3, and then the double bond O and the O and the C and the C, and everything else is just hydrogen. All right. So this guy is hydrogen. This guy is hydrogen, and this guy is hydrogen. All right. So what I will do is I'll just uh, duplicate this onto everyone. All right, and then this guy will get duplicated on the bottom. All right, and then this will be our other hydrogen. All right, this is the complete displayed formula of ethyl propanoate. And with that, this exam paper is completed. Do you guys have any questions?
No, sir.